pitch black, so you're just feeling around with your hands, trying to assess what you have down there.
Shotcrete is shut onto the wall and stays on the wall as a lining material.
A little bit of fear dealing with large pipe and sinking it 600 feet into the ground.
Welcome to the Sustainable Region. I'm Dagmar Timmer. Today we're in Capilano River Regional Park in North Vancouver, and right now I'm standing below the Cleveland Dam. But in just a moment, I'll get a chance that's rarely allowed, a tour inside the dam itself. The dam was built into a deep canyon in the 1950s and holds back 75 billion liters of drinking water. That's about a third of Metro Vancouver's supply. The Capilano watershed is one of three that supplies Metro Vancouver with our water. And here's a short primer that shows us how our drinking water gets from reservoirs like this one through to our taps at home.
The Greater Vancouver Water District delivers water to the region from three watersheds, the Capilano, Seymour, and Coquitlam. Collectively, these watersheds deliver the billion liters of water that pour from our taps daily. 500 kilometers of Metro Vancouver water mains crisscross the region before connecting to municipal water supply systems. Metro Vancouver conducts 25,000 tests of our water each year to monitor turbidity and other health concerns. Laboratories approved by the provincial health officer provide additional testing. Treatment of our water supply takes place through a variety of processes. Filtration removes particulate materials. Primary disinfection by ultraviolet and ozone kills bacteria and viruses. 8 rechlorination stations across the region provide secondary disinfection to prevent harmful bacterial growth as water flows through the distribution system. The recently completed Seymour Capilano filtration plant provides state-of-the-art treatment through filtration and UV treatment. Tunnels connecting the Capilano Reservoir to the filtration plant in the Seymour watershed are nearing completion and will be flowing water in 2014. A new ultraviolet treatment plant is being constructed to provide additional treatment to Coquitlam source water. Other major projects currently underway include the Port Mann water supply tunnel, ensuring delivery of water to municipalities south of the Fraser, and the Ridge water utility projects being built to meet the growing demand for water in Maple Ridge, Langley, and Surrey. The delivery of safe, clean water to Metro Vancouver residents is guided by the Water Management Plan goals of providing clean, safe drinking water, ensuring the sustainable use of water resources, and ensuring the efficient supply of water.
Check this out, a cantaloupe. And now, a plastic bag.
Kids, stop annoying the yard bin. Put all your food scraps and food-soiled paper into your yard waste bin, but no plastic bags, please.
We're here at the building that houses the new elevator to take workers and equipment way down into the dam to check on its operations. Hi, Joe.
Hi.
Well, Joe Jakes is the area supervisor for Metro Vancouver, and he's going to take us on our tour today. So, Joe, how far down are we going to go?
About 210 feet, which is about the height of a 20-story apartment building.
Okay, that's pretty far, actually. I heard that in that respect, I should be very happy we're in the new elevator rather than the old one.
Oh yeah, the old elevator was only made for one person. It's about the size of a phone booth. It took about 10 minutes to get down that one. This one is about 2 minutes.
That's great. Well, I'm really looking forward to seeing what's inside the Cleveland Dam.
Well, let's go.
All right. It's actually pretty comfy. Our next story also looks at workers who have to go underneath the surface to get their job done. They're marine divers in the Fraser River, and they're working on the Port Mann water tunnel project.
Up on that slack, make sure you got him, Abraham.
For commercial diver Rick Andrews, the next 4 minutes are critical. He's part of the construction crew helping build the new Port Mann water supply tunnel. and he's been underwater for about an hour, performing dangerous work in pitch black conditions. But when you've been more than 30 meters below sea level for that long, coming to the surface can be the most hazardous part of the process. It's crucial that Rick get inside the pressurized environment of this hyperbaric chamber to avoid decompression syndrome, also known as the bends. If he doesn't, nitrogen bubbles could form in his body, and the results can be fatal. It's just one of the construction challenges with this ambitious, complex project. The Port Mann water supply tunnel is a 3.5-meter diameter water main. It will be housed in a 1-kilometer tunnel under the Fraser River, just west of the Port Mann Bridge. Between Surrey on the south side of the river and Maquabeek Park in Coquitlam to the north. When complete, it will help ensure the reliable delivery of clean, safe drinking water to Metro municipalities. It will also double the capacity of the existing main. But before tunnel boring can start, deep vertical shafts must be constructed at both ends of the planned tunnel. When the project is complete, valve chambers will be constructed on top of the shafts in order to regulate the flow of water through the main. The 13-meter diameter south shaft will also be used to lower the tunnel boring machine into position, roughly 40 meters below ground. Part of the preparation involves removing materials and debris at the base of the shaft in preparation for pouring the concrete floor. However, the bottom of the shaft is below the water table. That means it's necessary to work underwater.
Yeah, let's get the diver in the water. Everyone focus on getting what Rick's going to need.
Commercial divers from Ballard Diving and Salvage have been contracted to prepare the bottom of the shaft. Usually, a total of 5 dives are made daily, with a 6th diver on standby in case an emergency situation arises underwater.
Today I was down there removing some plywood and some sections of 2x4 that they had installed inside of their metal box inside the casing. So far in this stage of the process, that has been pretty typical.
Once underwater, visibility drops to 0. The divers work in complete darkness, communicating via 2-way radio with the surface.
So you're on the wall right now, Rick? Roger, I'm right in front of me. Okay, let me start with Doug first. We're going to swing Doug left. Swing Doug left.
It's just pitch black, so you're just feeling around with your hands, trying to assess what you have down there.
After an hour below sea level, the diver surfaces.
Dive good, that's on surface. Okay, we got you on surface.
He'll spend the next hour in a hyperbaric chamber to allow the nitrogen that's built up in his body time to dissipate safely. To make sure the diver gets into the chamber within the 4-minute safety window, a support team helps him get out of his gear and into the pressurized environment.
We go into the hyperbaric chamber after our dive to fulfill our decompression obligations. We have a residual amount of nitrogen in our blood, and the residual nitrogen could cause decompression illness. So we go in the chamber for a certain amount of time to decompress and off-gas all that excess nitrogen in our system.
After entering the chamber, Rick will slow down and assess if he's sustained any physical harm.
Just relax, just lay down, just relax. Make sure nothing's hurting, nothing's aching, you know. Read a book and just relax.
When the south side shaft is ready for the floor to be poured, these preparations will be repeated at the base of the 8-meter diameter north shaft. The entire Port Mann water supply tunnel project, including site restoration once construction is over, is scheduled for completion in 2015. We all have too much stuff, but getting rid of it in a sustainable way is tough. Like all that old sports gear or that leftover paint that can't go to the landfill. Metro Vancouver's new We Recycle app turns your iPhone into a reuse and recycling powerhouse. It'll find the nearest place for your stuff to go. Simple, sustainable. Everything has its place. We Recycle, now available in the App Store.
Welcome back. I'm in one of the access galleries inside the Cleveland Dam. Joe, what does this blue pipe do?
Well, this blue pipe travels through the Cleveland Dam and transports water over to our residents in West Vancouver. Listen, Dagmar, I gotta get going, but I wouldn't mind introducing you to our senior project engineer, Gloria Grill.
I'd be delighted. Thanks. Oh, you must be Gloria. I'm Dagmar.
Hi. Hi, Joe.
Thanks so much again, Joe, and nice to meet you. Gloria, where are we going to go next?
We're going up to see the drum room.
Oh, great. So what happens in this room?
This room has some of the equipment that can be used in an emergency to change the water level in the reservoir.
You said emergency, so what happens normally?
Normally, all of this equipment can be operated remotely by computers at the new Seymour Capilano filtration plant.
How interesting. Speaking of Seymour Capilano, in our next story, we're going to meet the underground teams that are working on the Twin Tunnels project.
There aren't many construction crews like these. Most of their day is spent 185 meters underground. They're working on Metro Vancouver's 7-kilometer-long Twin Tunnel project. 2 parallel tunnels are being constructed to convey drinking water back and forth between the Capilano Reservoir and the Seymour filtration plant. Tunnel excavation work was completed in 2010, but as with household projects, the detailed finishing work goes much longer. This phase of work is called shotcreting.
In summer 2011, approximate period 6 months. Last 6 months, the contractor has been doing the shotcrete work. It is basically same as concrete. The difference with shotcrete is shot onto the wall and stays on the wall as a lining material.
Base camp is at the Seymour end of the tunnel. Workers take an elevator down into the 11-meter diameter tunnel, then load up the work train. It will carry them and their many supplies to today's work site. The passenger car is called a Mann rider. It's a cozy fit. At the work site, the work platform safety rails go up and the concrete is prepped. The shotcrete is made at a batch plant right at the construction site.
The contractor has a batch plant for mixing the shotcrete on the surface. They batch the shotcrete by using cement, aggregate, and water. After batching it, the material is lowered to the bottom of the shaft and is loaded into the concrete mixers that take the concrete to the location where the shotcrete is installed.
Shotcrete is transported through the tunnel in this torpedo-shaped vessel. It's called a Moran car. It holds 6 cubic meters of material, and in each 10-hour shift, they'll empty at least 3 of these. The spraying work begins. One nozzleman sprays water to ensure the rock surface is clean. Then the other follows with the shotcrete spraying at 90 psi. Workers wear protective gear, but still, it's messy work.
It's quite complex operation and it requires skilled and certified shotcrete applicators to do the work.
This round of shotcrete work was completed in 2012, but there will be more to do in 2013.
Welcome back to the Sustainable Region. I'm actually inside the Cleveland Dam, and I'm hearing this rumbling overhead. I was wondering, Gloria, is that the water?
Yes, it is. There's millions of liters of water that go into our transmission system, and about 9 times that amount goes right over the spillway over our heads.
So you're saying just 10% gets used for the drinking water. Is there talk about how to capture the force of that water?
Yes, there is. We are exploring the idea of putting in turbines to generate energy from that water.
Clean, renewable energy. That sounds like a great idea.
Metro Vancouver's watersheds are one of our most valuable resources, and it is important that we manage these systems carefully. As part of this process, Metro Vancouver has created a joint-use water plan for the Capilano and Seymour water systems. The main focus of the plan is to continue to provide safe, clean water, but it also focuses on protection of fish habitat and benefits to recreation. Exploring the possibility of hydropower projects on the Capilano and Seymour water systems has also been an important part of the consultative process.
We established this consultative committee in 2010 to bring together all of the key stakeholders that may be involved. The process was critical because we wanted to ensure we engaged everyone. We had technical studies done. We had public meetings.
Our primary responsibility is to provide clean, safe drinking water to the citizens of Metro Vancouver. We are committed to working towards using 100% renewable energy by minimizing our energy use and exploring green, sustainable options.
After 2 years of work, the consultative committee presented a plan which outlined the environmental, social, and economic benefits of the proposed improvements.
If we were to proceed in this direction, that the fish habitat would be better than it is now. We may be able to improve the recreation in the area. Most importantly, we keep our high-quality drinking water and the benefit of maybe generating some green energy.
On November 30th, 2012, the Metro Vancouver Board adopted the Joint Water Use Plan, allowing Metro Vancouver to take the first steps towards implementation.
So we have made an application to the Provincial Controller of Water Rights to see if we can proceed, but most importantly, we're doing a detailed business case to ensure that it has good financial sense and it works financially for us as a region. As we proceed, we're going to continue to consult with our stakeholders, we're going to continue to work on our business plan, refine it, and we're going to continue to have the greatest quality drinking water anywhere.
Welcome back. We're still inside the Cleveland Dam, and I'm standing here at a lookout point with Gloria, and it's about almost right at the bottom of the Cleveland Dam. It's a place almost nobody gets to go, and the view is unbelievable from here. Now, Capilano is just one of 3 reservoirs that we have supplying drinking water to Metro Vancouver. Furthest to the east is the Coquitlam Reservoir, and there work's been underway for the better part of a year to construct a new treatment facility. Let's have a look at that.
Since August 2011, Metro Vancouver has been undertaking a technological upgrade at the water treatment facility in the Coquitlam watershed. Once completed, the facility will comply with federal drinking water guidelines. However, in order to overcome the many obstacles in the way of this project, a spirit of innovation was required.
The close proximity of Coquitlam River and the high water table, the contractor had to lower the underground water table to enable himself to do the excavation. The other challenge that we had during the excavation was the close proximity of the hill right up above us. We had to install a huge retaining wall to hold that slope to enable us to do the construction.
In late August 2012, a large valve was installed that can stop the flow of water to the facility if future maintenance is required.
It is a butterfly valve made by the Zurich. It's one of the largest produced. The actual weight of the valve is 55,000 pounds. It was installed using a huge crane. Crane capacity was 270 tons.
Once the site is functional, it will use UV and soda ash in the water filtration process. Mayor Daryl Musato explained this at a press conference in September.
Chlorine has been used in drinking water treatment for decades. It will continue to be used as a secondary disinfectant to make sure we have high-quality water when it comes out of the tap. However, there are disease-causing organisms that chlorine is not particularly effective against, such as Cryptosporidium and Giardia. Ultraviolet light is highly effective at treating these microorganisms and produces no disinfection byproducts.
As the water passes beneath the tubes, the UV light sterilizes the microorganisms.
It is a very nifty type of technology. It does not add any type of chemical to the water, but still allows us complete disinfection.
The new facility includes various environmental features, such as a green roof, LEED design, and reclaimed heat and water conservation systems. With the project expected to be completed in 2013, there are still key steps left in the process.
The backfill in the immediate area around the Coquitlam UV has been completed during the summer of 2012. The remaining work is the mechanical work and the piping, including valving in the area of the chamber just located north of the Coquitlam UV facility. And that work is underway right now. All of the work is scheduled to completed by the fall of 2013, and the facility should be in operation by the end of 2013.
Earlier in the show, we saw workers spraying shotcrete inside the Seymour Capilano drinking water tunnel. Well, next up, we look at another engineering task on that same project, installing the tunnel liners.
This is the Capilano watershed. It provides drinking water to a third of the Metro Vancouver region, and in 2014, this water will receive UV treatment. For that to happen, a decade-long construction project has created 2 parallel tunnels to connect it to the Seymour filtration plant. The tunnels are 7 kilometers long, and in 2012, the lining phase of the project began. Each morning, the focus shifted to Anasis Island, where 680 tunnel liner sections were stored.
This steel pipe liner has been designed to be installed in both ends of the tunnel.
In proper order, the pieces are lifted up by a massive log sorter. Each liner weighs 31 tons.
The main purpose of that machine is for forestry, and because of the size of our pipes, we found that it is capable to fulfill our requirements.
The 12-meter-long liners are settled precisely into position.
Each truck is having an engineered cradle to carry the pipe.
Each workday, 4 liners are loaded and trucked out. The heavy load is carefully hauled through busy traffic, blending in with the many large rigs that ply the roads, and over the Iron Workers Memorial Bridge. The process was similar in the early 1950s, when large valves were transported to the Cleveland Dam construction project on the Capilano River. Far fewer vehicles were on the route then, and it traveled through Vancouver and over the tolled Lions Gate Bridge. Both truck drivers are part of the teams that help supply clean drinking water to the region. Arriving at the worksite, the installation crews take over.
I've never experienced something like this before, dealing with large pipe and sinking it 600 feet into the ground.
Inserting the long liners took some planning.
We need to put the pipes on an angle to lower down to the Seymour chamber. A device has been engineered and constructed with a winch system to bring pipe from horizontal to almost vertical.
That belly strap enables you to pick it up flat, and then your winch line enables you to vertically get the pipe into the right position. It was just a combination of a lot of things, and a little bit of fear, because you're dealing with 70,000 pounds.
Below ground, another team is standing by.
Operator at the surface and also the operator down below. Both monitor the three-dimensional location of the pipe and also what is the weight of the pipe.
The pipe is prepped to travel almost 7 kilometers on miniature rail platforms through to the Capilano end. Through 2013, liners will also be installed in the Twin Tunnel's Seymour end.
It's been a good project. I got a good crew and that's the major part of it.
We are seeing light after the tunnel and we are closing to the end of this project and everybody is excited.
Completion is slated for 2014.
Of course, operating this dam is only a small fraction of what Metro Vancouver does to ensure that our water supply continues into the future, even as our population continues to grow. Well, we'll hear more about that in future episodes, but for now, that's all the time we have. So don't forget that you can connect with Metro Vancouver through Facebook, and you can also email us at sustainableregion@metrovancouver.org and watch and share videos anytime at metrovancouver.org/videos. For the Sustainable Region, I'm Dagmar Timmer. Thanks for watching and see you next time.